All right, passport to advanced math lesson 7, and this is graphing quadratics. Okay, here are the standards number 1, 11, 5, and 12 with a heavy concentration on graphing quadratics and all the different parts. So first, quadratic function is in the form ax squared plus bx plus c, and you have to understand that the graph is always in the shape of what we call a parabola, which is a U-shaped graph. Okay. Now, in a parabola, in a quadratic function, you have a vertex, which is the highest or lowest point on the graph. When the graph opens up, or the parabola opens up, it's the lowest point. When it opens down, it is the highest point. Now remember, when the graph opens up, it has a minimum, meaning the vertex is the lowest point. So when your vertex is the lowest point, that is a minimum, right? And you have to understand that that happens when I have a function. If I have ax squared plus bx plus c, that's standard form, or a times x minus h all squared plus k, anytime your a value is positive, your graph will open up and your vertex will be a minimum. It is a maximum when it's the highest point on the parabola, when the quadratic opens down. So here your vertex would be the highest point, therefore it would be a maximum, right? And that is when your a value is negative. That tells you your parabola opens down. Now, you also have a y-intercept, right? Where, just like linear functions, it's the point where the graph crosses the y-axis. How do we find it? We let x equal 0, and it will be 0 whatever y is. Then you have x-intercepts, are the point, or basically is the point or points where the graph crosses the x-axis. So right away, it could have two x-intercepts when it crosses at 2 points. It could have one x-intercept when the vertex is on the x-axis, and it would have no x-intercepts if it does not cross the x-axis. Okay, so it can have 1, 2, or no x-intercepts. How do we find it algebraically? We let y equals 0 and solve the quadratic for x. So let's look at the first example here. The graph of y equals 2x squared plus 10x plus 12 is shown. If the graph crosses the y-axis at the point 0k, right here, what is the value of k? Well, here's the thing, the y-intercept. You're basically finding the y-intercept, so we're going to let x equals 0, so y equals 2 times 0 squared plus 10 times 0 plus 12. These wipe out because anything times 0 is 0, so y equals 12. Right there, k is 12. Second example, in the xy plane, the graph of the function f of x equals x squared plus 5x plus 4 has two x-intercepts. What is the distance between the x-intercepts? So anytime we're finding the x-intercepts, this is a no calculator question. So what we're going to first do is see if this is factorable. Are there any numbers that multiply to give me 4 and add up to 5? And those numbers would be 4 and 1. So I'm going to go ahead and factor that as x plus 4 times x plus 1. Now, here's the thing. To find the x-intercepts, I'm going to let y equal 0. So f of x equals 0 like this. And now I get one x-intercept is going to be at negative 4. The other x-intercept is going to be at negative 1. So if I were to plot these x-intercepts, negative 4, 0, negative 1, 0, what is the distance between? Well, right away I could see the distance. I go 1, 2, 3 units away. So there are 3 units apart. Sorry, that's not the best graph. I should do it a little better. Here's negative 4, 0, negative 1, 0. And as you can see, the distance 1, 2, 3 units away. The next one, which of the following is an example of a function whose graph in the xy plane has no x-intercepts? Well, here's the thing. A linear function whose rate of change is not 0. A rate of change that is 0, right, is going to be a horizontal line, right? So if it's not horizontal, it means it's diagonal or vertical, meaning it will have an x-intercept. Can't be it. A quadratic function with real zeros. If it has real zeros, that means it crosses the x-axis. Not going to happen. A quadratic function with no real zeros means there are no x-intercepts, right? And that would be the answer. Okay, the next one. The equation above represents a parabola in the xy plane. Which of the following equivalent forms of the equation displays the x-intercepts of the parabola as constant coefficients? So here's the thing, guys. When you look at this equation, which one can you identify the x-intercepts with right away, right? You have to know that this is not, you cannot get that right away. You cannot find the x-intercepts from this right away or this. So you know it has to be that. But how do they get that? Well, remember, the x-intercepts, you're basically going to let y equal 0. So x squared minus 6x plus 8 equals 0. And then you're either going to use the quadratic formula or factor. What numbers multiply to give me 8 and add up to 6? That would be minus 4 minus 2. Therefore, you can identify right away that one x-intercept would be at 4, the other would be at 2. So right away from this form, you can identify the x-intercepts, and that's what they're looking for. Next one, which of the following is the equivalent form of the function above for which the minimum value of f appears as a constant coefficient? So when they say a minimum value of f is minimum, right, remember, represents the vertex, right? So which one of these can you use to identify the vertex of this function right away? Well, the one thing that helps is, what is the vertex of this function? And we're going to do that real quickly one of two ways. Remember, if you understand and remember that when we find the x-intercepts, right, one x-intercept is going to be at negative 6, 0. The other one's going to be at 4, 0. So 1, 2, 3, 4, 5, negative 6, 0, and 4, 0. Remember, the x-coordinate of the vertex is going to be in the middle of those two zeros. So what value's in the middle here? Well, one way to do that is just take negative 6 plus 4, divide by 2, and you would get negative 1. So I know the vertex is going to be somewhere right here. Well, here's the thing. If the vertex is negative 1, if you remember vertex form, right, the x-coordinate of the vertex is at hk. And remember, we plug that into y equals a times x minus h all squared plus k. If the x-coordinate of the vertex is at negative 1, I know y is going to equal x minus negative 1 all squared plus some k value. Well, when I subtract a negative, that becomes positive, and right away, you should notice this is x plus 1 all squared, and that's the only one that has x plus 1 all squared, and I would get that. Now, if I did want to find what the value of k is, if I go up here and I plug that negative 1 in, negative 1 plus 6 times negative 1 minus 4, that's going to give me 5 times negative 5, which is negative 25, and that would be your k value, right? So this would be minus 25. The other way we can approach this problem, which is probably a little easier, right, is to go to our calculator, and I'm going to plug in x plus 6 times x minus 4. So I'm plugging that in exactly the way I see it. When I hit graph, right away, I see one x-intercept is at negative 6, 4, and the other one is at 4, 0. But I know my vertex is somewhere down here. So what I'm just going to do is go to my table of values, or I can zoom out on the graph if you know how to. But what I'm going to do is search for that symmetry, right? Oh, wrong way. And where do I see the symmetry? If I look here, I have negative 21, negative 21, negative 24, negative 24. When I look here, the symmetry lies at negative 1, negative 25. So I know my vertex is at negative 1, negative 25, and that's going to match up when I plug it into this vertex form with letter D. So you can use a calculator in a variety of ways for some of these problems. All right, next one. In the equation above, A is a constant. The graph of the equation in the xy plane is a parabola. Which of the following is true about the parabola? Well, right away, I know if this is negative, if my leading coefficient is negative, we said that was A. If that's negative, I know this is going to open down, which means this is going to be a maximum. Just by knowing that, I narrow it from a 1 in 4 chance to a 1 in 2 chance. Now remember, our vertex, we say our vertex is at HK, but we think the opposite of H, comma, K, right? So if this is minus 3, we know our vertex is going to be at positive 3, whatever that is, 3A. And that would be a maximum, and it occurs at the vertex of 3A. Okay? Now, next one. In the xy plane, the point 3, 6 lies on the graph of the function 3x squared minus bx plus 12. What is the value of b? Well, in this, I know x equals 3 and y equals 6. So what I'm going to do is substitute those in. This gets replaced with 6 equals 3 times 3 squared minus bx, b times x gets replaced with 3 plus 12. So 6 equals 3 squared is 9. 3 times 9 is 27 minus 3b plus 12. Well, now I'm going to solve for b. So 6 equals 27 plus 12 is 39 minus 3b. I'm going to subtract 39. I get negative 3b. Remember, that's negative 3b equals negative 33. When I divide by negative 3, b is equal to 11. So it's a gridded response, so I would bubble in 11. Okay, now the next one. Very similar problem. Again, know what you have and know how to use it. In the xy plane, the point 25 lies on the graph of the function f. If f of x equals k minus x squared, where k is a constant, what is the value of k? Well, again, x equals 2, y equals 5. Therefore, f of x gets replaced with 5 equals, I don't know k, but I know x is going to get replaced with 2 squared. So 5 equals k minus 4. Add 4 to both sides, and k is equal to 9. And that's what I would bubble in. Okay? Easy problems if you know how to approach them, which is why we're doing this. The next one. The function f is defined above. If k is a positive integer, which of the following could represent the graph of y equals f of x in the xy plane? Just by looking at this, if the leading coefficient a is positive, I know right away that that's going to open up, which means a and b cannot be an answer choice. What else can I recognize right away from here? I know one of my zeros, or x-intercepts, is going to be at the opposite of 3, which is negative 3, 0. Do any of the two choices here have an x-intercept. And remember, if you look here, my x-axis is here. My x-axis is here. So this x-intercepts at -2, 0. This one is at -3, 0. And just by knowing that, I know it's letter D. These problems, as you can see, there are a lot of them. And just by knowing the basic format of quadratic functions in standard form and vertex form, along with knowing how to find an x-intercept, the y-intercept, all of that stuff comes together and makes these problems really easy. All right, go ahead and try the mini assessments.